Alright, we're going to talk about the trig ratios. We're going to start with the right triangle. And the idea is that no matter what triangle that we have, and I'm going to start with a 30, 60 degree, 90 degree, where this is 2x, 1x, and x squared 3. No matter what triangle that I have, the angle, the acute angle 30 degrees, the ratios of the sides when looking through, like the eyes of the angle, 30 degrees here, no matter how big or how small the triangle is, the ratios of the sides are exactly the same. And first off, we're going to define the three ratios. The three trig ratios. The first one is the sine function. So it's going to be the sine of the angle. And we'll go with just angle A. And what we're going to say is this is going to be the opposite leg divided by the hypotenuse. So we have to know how to identify what's the opposite leg and what's the hypotenuse. The next one is called a cosine of A. This is sine. This one is cosine. It's not a typo. Sine is spelled without the G. This is going to be the adjacent leg to the angle that we're looking at, and over the hypotenuse. And the tangent of A is going to be the opposite leg compared to the angle A over the adjacent leg. And like I said, this is the tangent. So now, if I take just the basic 30, 60, 90 triangle, that's 30, that's 60 degrees, that's 90. And that's 2, 1, square root of 3. If I take the sine of 30 degrees, and I look at the angle 30 degrees, and I'll zoom in, so we can just take a look at this. For the angle 30 degrees, the opposite side is going to be the side that's farthest away. So this is opposite, the opposite leg of 30 degrees. Now this is the adjacent leg of 30 degrees. And the side opposite 90 degrees is always a hypotenuse. The nice thing is the hypotenuse will always stay the side opposite 90 degrees. It's just, what are the legs going to do? How are we going to change those? So, for the sine of 30, I want the opposite side, which is 1, over the hypotenuse, which is 2. So I get 1 over 2. Now the cosine of 30 degrees is going to be the adjacent leg, which is right here, the square root of 3, over the hypotenuse, which is 2. And the tangent of 30 degrees is going to be equal to the opposite side, which is 1, over the square root of 3. So, now, what I'm going to do is I'm going to show you that this is going to work for any other triangle. I'm going to dilate this, although I'm going to draw it to not to scale. I'm going to multiply every value by, let's say, 15. So 2 times 15 is 30. 1 times 15 is 15, and this will be 15 radical 3. That's my 30 degrees, 60 degrees, and my 90 degrees. So my sine of 30 degrees is now going to be the opposite side. So I have to find the opposite side. It's the farthest leg away from 30 degrees. That's my 15. And I'm going to take that and put it over the hypotenuse, which we figured out was 30, so it's 15 over 30. Well, I'll write it down here. That's 15 over 15 times 2. The 15's divide out, and I'm left with 1 in the top and 1 in the bottom. So this is 1 over 1 times 2, which is 1 over 2. So I ended up finding out that the sine of 30 for this triangle, which had totally different sides than the original, was 1/2. Well, same thing over here. Let's see if the cosine works. Cosine 30 degrees is going to be the adjacent side, 15 radical 3 over the hypotenuse, which is 30. 15 divides into 30 2 times, so I could say 15, that's a 1, 30, that's a 2, so I get square root of 3 over 2. That's exactly what the cosine was in the original, and the tangent of 30 degrees, hopefully I end up the same way. I need to take the opposite side, which is 15, over the adjacent side, 15 radical 3, divide them out, and I'll have 1 over square root of 3, which is exactly what the tangent was over here. So, we have our defined sine, cosine, and tangent, which is just the ratio of the sides. Each angle has its own specific values. Like the sine of 60 is not the sine of 30. The sine of 31 is not the sine of 30. Every angle has its own unique sine, cosine, and tangent. This is just kind of like an introduction to the whole idea of sine and cosine, and I wanted to use a triangle that we knew in order to kind of show that, alright, the sines work. The sine of 30 degrees here was half, the sine of 30 degrees here is half, so I know it's only 2 examples and we need an infinite number of examples to make it work, but trust me, type it into your calculator. Sine of 30 degrees is 0.5. We will be doing a lot more of this in class. If you got any questions, just ask. See you next time.